Okay, this lesson is our start on quadratics, and we're just going to review some terminology. You should have printed out the Word document or the PDF document. They're the same thing, just in a different form. And it just gives you a place to take your notes on and put that in your notebook. So on your printout, you should have a quadratic that looks something like this, the parabola. And let's just start by identifying a few things on here. First of all, we want to locate the vertex. And the vertex is, let me pick a different color right there. This point is the vertex right here. Vertex. And we're going to label that point H. Okay, that kind of looks like a J. Let me get rid of that in a minute and make a comma there. So the coordinate point HK is the vertex, and this looks similar to the circle, where we had HK was the center of the circle. Let's now identify the axis of symmetry. The axis of symmetry is always a vertical line. It always goes through the parabola, through the vertex. So that is our axis of symmetry. That's important because even though I kind of crudely sketched this here, it's important because the axis of symmetry says if I have a coordinate point over here, then over on this side I have another coordinate point. We'll call this one x sub 1, x sub 2, but the y coordinates are the same. The y coordinates are the same because it's the same y value on here. And that holds true for every point on the quadratic, on the parabola, with the exception of the vertex, of course, because it only has one point right there. The y-intercept, let's identify those. Let's pick this turquoise color. So the y-intercept, right here, here's our y-axis. So there's our y-intercept, y-intercept, and that's the point at which the parabola crosses the y-axis. Okay. So we also want to note if this vertex is a maximum or a minimum. Let's change to a different color. This vertex is at the top, it's the uppermost point, so in this case it's a maximum. If I had a quadratic that looked like that, and its vertex was right here, well, that would be a minimum point. Oh, and I asked you to do that, so go ahead and sketch that on your paper there. Now we want the general form of a quadratic equation. The general form looks like this. People are familiar with this. ax squared plus bx plus c, and this equals f of x. And I think there's a place for you to write that in on your form like that. So there's the general form of a quadratic equation. And then I ask you if by looking at this, so let's pretend, let's put some variables, there's some constants in here for the variables. 3x minus 2. Let's have that equal to 8 or something like that. And I asked if how you know that this opens up or down. You might recall that the a or the leading coefficient or the coefficient of the x squared, all those things mean the same thing. If this is a positive number, that means it opens up, and if it's a negative number, that means it opens down. And then the last one we want is the vertex form. So the vertex form, I'm going to squeeze that in right here. You have plenty of room on your paper. Vertex form of the quadratic looks a little bit different than that. Okay. So vertex form, f of x equals, we still have that leading coefficient a. Now we have parentheses x minus h quantity squared plus k. The reason this is called the vertex form is because there's h and there's k, which is the vertex. So this concludes our review lesson on terminology. We'll pick up with the next lesson on vertex form.